Hello everyone. We are going to see deadlock avoidance using Banker's algorithm. You people know deadlock in the sense a waiting scenario, right? So here we have a question considering a system with 5 processes P0 through P4 and 3 resources of type A, B, C. Resource type A has 10 instances. Totally how many instances? 10. B has 5 instances. C has 7 instances. So here they have taken a snapshot of a system at the time T0. We have 5 processes P0, P1, P2, P3, P4, each as allocated with some resources, and we have given the maximum resources to be allocated to each processes and the available resources. In some cases, they won't give the available resources. In that case, you want to find out what the available resources is. So how to calculate in the sense, see, A has 10 resources, right? So totally we have allocated, just see here, totally for resource type A, we have allocated, 2, 3, 2, totally 7. 7 we have allocated. So what would be the available? Total 10, the available resources 3. Then for B, see here, we have allocated 2, totally 5, so 3 would be available. So in that way, you want to find out the available, if not given in the sense. Right. Here we have a question, is the system in a safe state? And what would be the content of need matrix? Then what are the total number of resources available for each resource type? And the resource request from process P1 arrives for 1 to 1. Can it be granted immediately or not? So this is what our question is. So let's see one by one. If you want to implement Banker's algorithm, you need to be thorough in 2 algorithms, safety and resource request algorithm. Safety algorithm, here we have a safety algorithm. Finish of I is equal to false. That means the process is not yet completed. If so, what we want to do? Finish of I is equal to false, need less than or equal to available. If it's so, we can go for what? The next step. So if we want to update the available, then we have to make our finish as true. That means we have completed that work. When our need is less than or equal to available, when our need is less than or equal to available, we have to update the available value as old available plus allocation of the current process. So once it is completed now, we can return the allocated resources for that particular process. So that is what they have given here. So once you complete the step, you can make your finishes true. That means the process is getting completed now. The same way we have a resource request algorithm. Here we have to check some conditions. Your requested resource should be less than or equal to your need, as well as your requested resource should be less than or equal to available. If so, you can proceed. So what you want to update now? You want to update the available value and allocation of that particular process who is raising the request, and you want to update the need matrix of that particular process. So this is what our question is, right? So here we have 5 processes totally. First, we are going to find out the need matrix. So what would be the need matrix value? We have a formula, maximum minus allocation. So 7 minus 0 returns 7, 5 minus 1 returns 4, 3 minus 1, sorry, 0 returns 3. So in that way, we are updating the need matrix. We have to subtract the maximum value, allocation value from the maximum value. So here we have the formula for need matrix. This is what the question answer for that need matrix question. So next we want to check whether your system is in safe state or not. So how to check that? First, initially we have to take every process as false. That means not yet complete. Okay. So we'll start with process P0. So first I'm taking I is equal to 0, that is P0. I'm comparing my need matrix. What would be the safety algorithm? Need should be less than or equal to available. So 743 less than or equal to available. What is available here? 332. So 743 less than or equal to 7, 4, 3 less than or equal to 3, 3, 2. See here, available is 3, but I need 7 for resource type A. How can I allot that? I couldn't, right? So, we can't proceed the process 0. Okay, I can move to the next process. So, what is the next process P1? Need is 1 to 2. So, I have to compare this 1 to 2 with my available 332. See, 3 available for A, I need 1. I can provide, right? The same way, 3 available in B, I need 2. I can provide. So, 2 available in C, I need 2 also, right? I need 2 only. So, I can provide. So, this process is possible, right? So, I can complete my P1. So, in my save sequence, I have to add P1 and I have to make my P1 as true. That is my first step. Right. After once I make my P1 as true, what I have to do? I have to update my available value. What is the formula? Available is equal to available plus allocation of I. What is the allocated resource for P1? P1 allocated resource that should be taken from your input data. Allocation for P1, it is 200. So I have to add 200 with my 332. So I'll get 532. So this is what my new available. I can proceed my next process with this new available. So in the same way, I'm going to proceed my uh, uh, the next process, that is P2. So P2 needs 600. Available is 532. So I couldn't, right? So 5 I couldn't, right? So I cannot proceed my P2. I can go with my P3. P3 need is 011. Available is 532, which is lesser, right? I mean 011 is lesser than 532. So I can proceed my P3. So in my save sequence, P3 will be added and I have to update the available value. So for the next step, my available would be 743. And I have to make my P3 as true. So in the next step, I am proceeding with P4. P4 needs 431. Available is 743. It is possible to provide that resource. So I can complete my P4. Once I completed my P4, I have to update my available value. So next, I can, P4 up to P4 completed, no? Still we have two more process to complete. P0 and P2 is there, right? So I can start with P0. P0, uh, uh, the need for P0, I can go with P0. Then I have to update the P0 value as true. Then I have to update the available value. Then I can go with P2. So P2, I can satisfy the need of P2 with the new available resource. So after that, I have to update my available value. See the final value, this is equal to the total number of resources. So that is what the question asked, right? So resource type, how many resources available at the end? So we got the total number of resources as A10, B5 and C7. So here is what the save sequence is. When your process is getting completed, you want to add that process in the save sequence. What does it mean? If I am executing all my process in this order, my system won't be affected by deadlock. This is what the solution is. Then what about the last question? If a request from P1 arrives for 1 to 1, can the request be granted or not? So here request is 1 to 1. So I have to check with the resource request algorithm. So resource request algorithm tells you first I want to check request is less than or equal to available. What is the request? 1 to 1 is less than or equal to 332. It is lesser, right? So I can go with the next step. Need less than or equal to my request should be less than or equal to need. So 1 to 1 is less than or equal to 122. So I have to check these two conditions. After that only I can proceed my values. So how can I proceed? I have to update the value of allocation, available and need. With that new value, I have to proceed my again I have to proceed my safety algorithm. You would get the same for this set of data, you would get the same result. So that means the request can be granted by the system. Thank you.